A ball is thrown upward from a balcony, and its height is modeled by a quadratic equation. The general formula for the height of a projectile includes gravitational acceleration, initial velocity, and initial height. The ball will hit the ground when its height equals 0. To find when the ball hits the ground, we set the height equation to 0. We will use the quadratic formula to solve for time, where a, b, and c are coefficients from the equation. First, we calculate the discriminant, which helps determine the nature of the roots. The discriminant is calculated by squaring the coefficient b and subtracting 4 times a times c. Calculating the discriminant gives us a value that indicates how many solutions exist. Next, we find the square root of the discriminant to use in the quadratic formula. Now we can calculate the two possible time values using the quadratic formula. For the first time value, we add the square root to negative b and divide by 2 times a. Calculating this gives us a negative time, which we discard since time cannot be negative. For the second time value, we subtract the square root from negative b and divide by 2 times a. This calculation gives us a positive time value, indicating when the ball hits the ground. The ball hits the ground at approximately 2.58 seconds after being thrown. To find the maximum height, we use the vertex formula, which gives the time at which maximum height occurs. Calculating the vertex time involves using the coefficients from the height equation. Now we can find the maximum height by substituting the vertex time back into the height equation. We first calculate the square of the vertex time to use in the height equation.